Okay, section 2.5, transformation of functions. Listed below are some common algebraic functions and their graphs. You should memorize these graphs. These will also be known as called, when you watch some videos, if you do YouTube sort of thing, these are also known as parent functions. These are kind of our original starting points, or otherwise known as parent functions. I've seen some videos refer to this as a library of functions, whatever you want to call it. But here are the basic functions that we're going to be working with in this section. Now, even though we're only working with these 5 functions in this section, what we're learning is true for all functions. So for those of you that have to go on to trigonometry and you learn about shifting trigonometric functions, the same principles will apply. So we've got the standard quadratic function, f of x equals x squared. Its graph is a parabola. It looks basically like that. Square root function, f of x equals square root of x, and there's its graph. The standard cubic function, f of x equals x cubed. Its graph looks like that. The cube root function, and notice it's almost the same, but not quite. But it looks like that. And then the absolute value function, and the absolute value function comes to a sharp V. 2 straight lines, sharp point. The parabola is a U shape. The sides are gently curving. They are not straight lines. They may look like straight lines, but they're not. It's gently curving. So there are basic shapes that we'll be dealing with, what some people refer to as parent functions. And what we're going to be doing is moving these guys around. So the first thing we're going to talk about is vertical shifts. So I've picked on x squared, and so I've graphed here f of x equals x squared, g of x equals x squared plus 5, h of x equals x squared minus 10. And then we're just going to highlight these. So in blue is the f of x squared, and it's the one in the middle. So there's the x squared, what we're referring to as the parent function. Then let's pick on yellow, the x squared plus 5. That's this one here. And notice that the graph is that same basic shape, but shifted up 5 units. That's what the plus 5 on the end did. And the x squared minus 10, we'll do that in green. Down here. Or x squared minus 10. And notice all it did was drop that basic parabola shape down 10 units. That was the effect of the minus 10. And so what we're seeing demonstrated here are vertical shifts. Now, in general, let f of x be a function and c a positive real number. The graph of y equal f of x plus c is the graph of y equal f of x shifted up c units. The graph of y equal f of x minus c is the graph of y equal f of x shifted down c units. So a number that's added or subtracted on the end shifts things vertically. Up if it's plus, negative if it's down. And so what this is saying is just take whatever the shape of f of x happens to be, whatever graph you're looking at. If you're adding, then move it up that many units. If you're subtracting, move it down that many units. Okay, let's see it in action. So we got a graph there. Given below is the graph of y equal f of x. Use the graph to graph f of x minus 2. And so what they're saying is, here's your basic shape. Graph this guy. Now on a test or quiz, on a test, if I gave you something like that, I'm just going to look for something that looks like you tried. But what we're going to do here is we're going to move each one of these points. So this point right here looks like it is 1, negative 2. Or except negative 2, 1. So negative 2, 1 is that point right there. And let's graph our answer in green. Answer in green. That's not how you spell green. Let's spell green correctly. Answer in green. So I'm just going to do a little rough mock-up of the original thing. So we had that point -2, 1. We have the point here -1, 1. So, yeah, -1, 1 right there. Then we have the origin 0, 0. Then we have the point 1, -1, so right there. And then lastly, the point 2, 1. And so there's my original graph, right there. There's my original graph. So we just want to draw a new graph, but shift it down 2. Y equal f of x minus 2. Shift down 2 units. So I'm going to take each one of those points that I did. So this was the original guy. I just took my original guy, and I'm just going to shift these points down 2 units. So 1, 2. There's that point. 1, 2. Shift it down. 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 Then I took each one of the points from the original graph, shifted them all down 2, and there's my answer. Now, on the computer, this sort of graph right here is multiple choice, and you just pick your problems. You just pick the right answer. Now, a lot of these, some of the problems aren't multiple choice. When we get to things that have regular, I don't know what I mean by regular, but you have, kind of normal things, not something weird like this, but normal. That's not necessarily multiple choice. If they have ways that you can graph. My technology setup right here will not let me show you what I see on my computer screen, so I can't bring up how to do the graphing in MyLab Math. So if you're having issues when you come to doing the homework on MyLab Math, if we're actually open, you can come and see me for help. If we are online or whatever, contact me, and if you can't figure out how to do the graphing, contact me, and I'll try to walk you through the graphing. But my technology setup here won't allow me to share my computer screen. Hopefully the technology will get a little bit better later on to allow to share my computer screen, but it doesn't right now. So all I can say here is if you have issues when you're in the computer doing the graphing, contact me, or if we're actually open, you can go to one of the tutorial centers, maybe they can help you, but we will work it out. But graphing this guy here. So here are my thought processes. My basic shape comes from the square root, which looks essentially like that. That's why you just want to memorize those basic shapes. The -8 is a vertical shift down 8 units. So come test time, if this is a handwritten test, if you're in one of my smaller classes and it's a handwritten test, come test time, all I'm looking is for that basic shape shifted down 8 units. So I'm going to take that origin point and just move it down 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So there's -8. That's that origin point and the same basic shape. That is all I am looking for. That we're just going for the broad strokes here. Do you know what the shape of the graph is? Do you know what that -8 does? That's good enough. Next one. Same idea. My basic shape comes from the absolute value, which is that V shape. The +5, vertical shift up 5 units. And I'm going to do the same basic thing. I'm going to take that origin point and just shift it up 5 units. 1, 2, 3, 4, 5. And then I'm going to draw out that same basic shape, and that's good enough. I am just looking for the broad strokes here. Because that's vertical shifts. Horizontal shifts. So shown are the graphs of f of x equals absolute value of x. So we'll do that guy in blue. And that's this one here. G of x equal x absolute value of the quantity x minus 5. And we will do that guy in green. And that's this one here. And so we see that it's shifted horizontally, but it shifted to the right 5 units. Even though there's a minus 5 here, it went right 5 units. And in yellow, the f of x equal x plus 10, which is this guy right here. And we see, too, that it is shifted horizontally, but the plus 10 inside that absolute value, in with the x, shifted it left. And so a number inside the absolute value, inside the function, in with the x, is a horizontal shift, but it goes opposite to what you'd expect. If it's plus, we go left, and if it's minus, we go right. So summarizing that, let f of x be a function and c a positive real number. The graph of f of x plus c, f of the quantity, x plus c, the c is inside the function, it's in with the x, is the graph of x shifted left c units. Plus sends us left. The graph of y equal f of the quantity, x minus c. It's inside the function. Is the graph of y equal f of x shifted right c units? So when the number is added or subtracted inside the function, in with the x, it's horizontal, but it goes opposite to what you expect. If it's plus, it's going to go left c units, and if it's negative, it's going to go right c units. And that's where we'll end this video, and we'll pick up with it on the next one.